Our topic is metallurgy. Today we are going to discuss about the extraction of moderately reactive metals. As you know that before this topic we discussed the extraction of least reactive metals. So this is the second part of that extraction of moderately reactive metals, and you know that moderately reactive metals are zinc, iron, tin and lead. These are some examples. These are placed in the middle of the reactivity series. So we how are moderately reactive metals extracted from their ores? The whole process which is used for this extraction is reduction. If you remember that in our last topic, that is in the extraction of least reactive metals, their metals are extracted by using calcination and roasting. In this process, calcination and roasting are needed, but the reducing agents here are used. Carbon, it is used in the form of coke, aluminum in the form of aluminum powder, sodium or calcium. These are some reducing agents that are used in the extraction of metals. So metals, it is easy to obtain metals from their oxides, as we know, by using an oxidizing agent, but these moderately reactive metals are present in the form of two types of ores. First one is carbonate and second one is sulfides. As we know, oxides are easily reduced to metals, but when these are present in the form of carbonates or sulfides, these are the two processes that are used for their reduction or for their extraction. First one is calcination and second one is roasting. So when is calcination and roasting used? If the ore is present in the form of carbonate, it is calcinated and then reduced. But if the metal is present in the form of sulfide, the ore is first roasted and then reduced. Zinc, it is the moderately reactive metal. It is present in the form of zinc carbonate and its ore is called as calamine and its chemical formula is ZnCO3. It is also present in the form of sulfide. Its ore is zinc blende. Zinc carbonate and zinc sulfide are first converted into zinc oxide by calcination and roasting. This is the overall reaction of extraction of zinc carbonate. As you know that calcination is the process in which an carbonate ore is heated in absence of oxygen to form an oxide, and after that, this is the first step, and after that zinc oxide is reduced to convert it into zinc. In the same way, what is roasting? Roasting is the process in which sulfide ores are heated in presence of oxygen and converted into metal oxide, and that metal oxide is then reduced to form metal. We will study one by one that how are metals calcinated and roasted. So first one is zinc. It is present in the form of zinc carbonate. First we will study its extraction. It is completed in two steps. First step is zinc carbonate. It is converted into zinc oxide plus carbon dioxide. This is the process of calcination. You will note it down that this is zinc carbonate and this ore is called as calamine ore. It is first step. In this step, zinc carbonate is calcinated. Calcination means the breakdown of carbonate ore in absence of oxygen to form zinc oxide and carbon dioxide. So here in first step we get zinc oxide, we will get a metal oxide. After that, in the second step, this zinc oxide is reduced in presence of carbon. This is its second step, zinc oxide. So in zinc oxide we will use carbon in solid state, and in this process we will get zinc plus carbon dioxide. So this zinc is free metal, it is metal in free state. You will see that this reaction, it is a type of reduction. It is reduction process. Reduction means removal of oxygen from a compound, and here oxygen is removed from zinc oxide by reducing agent. And what is reducing agent? The substance which removes oxygen from a metal oxide, or which is responsible for the reduction of a compound. So it may be also called as a displacement reaction, because here zinc carbon takes the position of zinc. Carbon comes in place of zinc because carbon is highly reactive. Carbon is highly reactive than zinc, so it displaces it. So this type of reduction is also called as displacement reaction. So this is the process in which zinc carbonate is converted into zinc metal. Number second, zinc is also present in the form of zinc sulfide and its ore is called as zinc blende. So in the same way, in first step, zinc sulfide is roasted. Calcination means heating of a carbonate in absence of oxygen, and roasting means heating of a sulfide in presence of oxygen. In this reaction, zinc sulfide, when it reacts with oxygen, it will get converted into zinc oxide and sulfur dioxide. This is the first step of extraction, and in second step, in the same way, zinc oxide is reduced in presence of carbon and it is converted into zinc plus carbon monoxide. So in the two processes, calcination as well as in roasting, we will get metal in free state. It is free state. This is the extraction of zinc. Second example of a moderately reactive metal is iron, or the reduction of a metal with aluminium. In the last two processes we studied the reduction of metal by carbon, but carbon does not reduce all the metals. What is the reason behind that? You will see here, carbon, it displaces, carbon displaces zinc, and you know that what is displacement reaction, in which a highly reactive metal displaces a less reactive metal, that is displacement reaction. But if the elements are manganese or chromium, these are more reactive. These two metals are more reactive than carbon. That is why carbon cannot displace manganese and chromium from their oxides. So aluminum is used in those cases where the metal oxide is of a comparatively more reactive metal than zinc. zinc is less reactive than manganese and chromium. If highly more reactive metals are present, if the oxides of the more reactive metals are present, in that very case carbon will not reduce it. So we will use aluminum in the form of aluminum powder as a reducing agent. For example, manganese and chromium, oxides of manganese and chromium are reduced by aluminum because these are more reactive than carbon, so carbon cannot reduce them. So aluminum powder is used as an oxidizing agent. This is the whole reaction. Now I will show you how this reaction takes place. So first one is manganese. Manganese is present in the form of manganese oxide, or it is also called as manganese dioxide. It is reduced. We have to extract manganese from it. So we will not use carbon as a reducing agent, because I will show you, if carbon is used as a reducing agent, this reaction will not take place, because carbon is least reactive. It is least reactive than manganese. Carbon will not displace manganese from its oxide. That is why we will use aluminum in place of carbon as a reducing agent. Manganese plus aluminum, so it will form manganese plus aluminum oxide plus heat. You will balance this reaction. 2 times, 4 times, 3 times, and 3 times. So this is the reduction of manganese oxide by aluminum. So aluminum is highly reactive than manganese. It will displace it. Manganese will be extracted from this oxide, and we will get manganese in free state. So this is also a type of reduction as well as displacement reaction. So you will see that in this reaction heat is evolved, a large amount of heat is produced. So during the reduction of manganese dioxide, when it is reduced with aluminum powder, because of which manganese metal is produced in molten state. It is not produced in solid state, it is produced in molten means in liquid state, because a large amount of heat is evolved in this reaction. So the type of reaction, that the reduction of metal oxide to form metal by using aluminum powder as a reducing agent is called thermite reaction or thermite process. So this is a type of thermite reaction in which metal is extracted, metal is reduced in presence of aluminum powder, and in which a large amount of heat is evolved. That is why it is called as exothermic reaction. These are some important points of thermite reaction. First one is, it is the process in which reduction of metal oxide to form metal by using aluminum powder as a reducing agent. Number second, it is highly exothermic in nature because a large amount of heat is produced. Number third, metals are always produced in molten state. So there are a large number of uses of thermite reaction. First is, it is used in thermite welding for joining the broken pieces of heavy iron objects like girders, railway tracks, or cracked machine parts. You must have noticed it. What As you know that what is a what is welding? Welding is a process in which broken pieces of iron objects are uh, attached with each other. So how are broken pieces bonded or attached with each other? By using aluminum powder. This is for example iron oxide Fe2O3 plus aluminum, it will form iron metal aluminum. This is also the reduction of iron oxide. Iron oxide is also reduced by aluminum because carbon is less reactive than iron. It will take place in this way. This is Fe2O3, it is the ore of iron. It is reduced by aluminum. Here we will get iron aluminum. It is a type of displacement reaction. Iron will be extracted, it will form Al2O3 plus heat. Iron will be extracted in liquid state. This is aluminum oxide in solid state, and a large amount of heat is uh, produced. So how is iron used? This iron is present in liquid state. If two parts of if two broken parts are present, this molten iron is poured in between them, between the broken pieces, and these are attached back with each other. This is the process of aluminothermy or thermite welding. So this whole process is called as the extraction of moderately reactive metals. So in the next topic we will study the extraction of highly reactive metals.